Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 5.7 guided notes on solving proportions. We worked with proportional versus non-proportional relationships, but we haven't specifically defined or stated what proportions are. Well, proportions are just equations stating that two ratios or rates are equal. The cross products of a proportion will be equal to each other. This helps us because if we're given a proportion, like the examples 1 through 7 down below, and we have a missing value in that proportion, we can solve for it by cross-multiplying and solving the resulting equation. This is also going to apply to some algebraic concepts. When we get to problems 27 through 29 in these guided notes, you'll see some questions similar to what you might see in algebra. Proportions are used for a lot of different word problems in real-life situations. We'll talk about some of those as we approach those examples in these guided notes. So let's go through the really basic, straightforward questions to begin with, and then we'll get into some more complicated word problems. So number 1, we have x over 9 equals 16 over 12. I'm trying to solve for x, so we're going to cross multiply. Take 12 times x, set that equal to 9 times 16. 9 times 16 is 144. So right here where my mouse is, we get a one-step equation. We solve that by dividing both sides by 12, and we know that x equals 12. Now, I also recognize that some of these fractions are pretty easy, that you might be able to find your solution without cross-multiplying. However, we are going to see some more complicated questions that involve decimals and fractions. And even when we get to problems, like I said, 27 through 29 in these guided notes, you have to have an understanding that cross-multiplication will work to help us solve for a missing value in these proportions. So I'm going to show you that for every single one of these problems, despite the fact that some of them can be solved in other ways. So number 2, I'm going to cross multiply here. I'm going to take 28 times w, set that equal to 7 times 32. So we get this. Now I'm going to suggest that moving forward, you skip this yellow highlighted step and go right to our next step, which will be 28w equals 244. I'm going to show it for each of these questions, even though I do suggest you start to skip it. Divide both sides by 28. We will get a value for w of 8. So 224 divided by 28 is 8. Now I know some of you might have been able to look at this and think, well, I know 7 times 4 is 28, and I know that if something times 4 has to equal 32, that something, that w, needs to be 8. Keep in mind, that works great for this problem, but there may be other problems where those numbers aren't as compatible, and we might not be able to do it mentally. So that's why I show you this strategy. Number 3, let's take 36 times s and 21 times 24. Again, you can go right down to the second line here, which is 36s equals 504, especially as advanced students. Divide both sides by 36, and s will be 14. All right, let's move right ahead. Number 4. We'll cross multiply here, and again, I know this is an easy one to calculate mentally, but we'll take a times 56, set that equal to 8 times 42. So I would go right down to your second line, which is 56a equals 336. Divide both sides by 56 to get a value of a, which is 6. Again, this one might be easy for you to figure out, since 56 divided by 8 is 7, and 42 divided by 6 also gets you 7. You do notice, though, when we get to number 5, we've got some decimals. So that's where things get a little bit trickier and where it does benefit us to use cross multiplication. So let's do number 6. I'm not going to read through number 5. Feel free to look at it on your own if you need to. So let's do 3.5 times d and 21 times 1.5. That will get us 3.5d equals 31.5. Divide both sides by 3.5. And we get a solution of d equals 9. All right, let's see the last question on this, and then we'll give you some independent practice on these problems. So we'll do 121 times z, set that equal to 22 times 16.5. That will get us 121z equals 363. Divide both sides by 121, and of course, z will equal 3. It won't always equal whole numbers like it does on some of these other questions. You'll sometimes get some answers that are decimals or fractions themselves. All right, here's 2 independent practice problems for you to try. Go ahead and pause the video, give these 2 questions a try, and when you're ready, unpause the video, and we'll take a look at these solutions. All right, how'd you do with these questions? Hopefully pretty well. So let's look at number 1. 2 times c is 2c. 4.4 times 25 is 110. Divide both sides by 2, and c has to be 55. Number 2, we do 12 times p to get 12p, 4 times 7.2 to get 28.8. Divide both sides by 12. Here we do get a decimal for that solution. P equals 2.4. All right, moving ahead to our next concept. So you don't have to copy anything down in that box. This is already in your notes. But at the top of the next page, it says to determine whether a pair of ratios forms a proportion, find the cross products and see if they are equal. So in these questions, we're going to notice, and I apologize that these are numbered wrong on here. I must have changed some questions previously and fixed the numbers on your notes. So just follow along. I know number 10 here is number 8 on your page. So it says determine whether each pair of ratios forms a proportion. So I have 1/5 and 4/20. I want to see if those are equal. So guess what I do? I take 1 times 20 and 5 times 4. Both products give me 20. So yes, they do form a proportion. They would be equal. In number 13, if I have, well, actually number 11 on your paper, if I have 4/9 and 2/3, I can take 3 times 4 and 9 times 2. 4 times 3 is 12, but 9 times 2 is 18. Those cross products aren't equal, which means those ratios cannot form a proportion. It's the same question as asking, are those fractions equal to each other, which you can also do by just figuring out what they are as decimals and seeing that they're not equal to each other. We did cross products a little bit previously when we were comparing two fractions. We cross multiplied to see which product was greater or whether or not they were equal to each other, so we could easily compare two fractions. So we have seen this before, just not using the term proportion when we were working through that. So let's take a look at number 11, which is actually number 9 on your paper. We've got 3/8 and 12/32. So one way to figure out if these form a proportion is to take 3 times 32 and 12 times 8 and see if those products are equal. They are. So these will form a proportion, meaning the two fractions are equal to each other. So pretty straightforward. Do you have to cross multiply to figure that out? No. You could actually just simplify 12/32 and see that it simplifies to 3/8 and you're good to go. Let's try number 12 here, which is number 10. Oh God, goodness, my son is screaming over there. Number 10 on your paper. So we'll take 3 times 36 and 4 times 27. Both cross products give us 108, so those two fractions do form a proportion. All right, number 14 here is number 12 on your paper. So let's take 10 times 4.2 and 5 times 8.4. They both equal 42. So these again do form a proportion. That one might be beneficial to do cross products versus trying to simplify, but you could take 10 divided by 8.4 and 5 divided by 4.2 to see that those quotients are both equal as well. So number 15 here is number 13 on your paper. We're going to do 9 times 4.8 and 12 times 3.2. Those cross products are not equal. You had to figure out there would be at least one of these that we did that wasn't going to form a proportion. This is that example. 12 times 3.2 is 38.4, and 9 times 4.8 is 43.2. All right, moving ahead to the next concept where we start to get into some word problems, some pretty straightforward ones. So this is numbered correctly, thank goodness, on here. So number 14, it asks us to write a proportion that could be used to solve for each variable. Now you might be thinking, I could answer number 14 without writing or setting up a proportion. That's great, but not every question is going to be as easy. Plus you might have some questions on a test or a quiz that say you have to use proportions. So that's the way I'm going to show it here. So number 14, we've got 12 fish in 4 aquariums, 9 fish in X aquariums. We want to figure out how many aquariums we need for 9 fish. So when I'm doing problems like this, I look at the two things that we're talking about in the problem. In this case, it's fish and aquariums. Do you have to put fish on top and aquariums on the bottom? No. I just keep them in the same order in which they're written. You could write aquariums over fish, but it will change our other fractions as well. So my first ratio, my first fraction, is going to come from this first statement, 12 fish to 4 aquariums. So I can write 12 over 4. My second ratio or fraction is going to come from this, 9 fish in X aquariums. So we have 9 over X, since we're trying to solve for X. Sorry, my son's being pretty loud. He's walking around, slamming doors. Goodness, that's just his nature. So we're going to cross multiply here. We take 12 times X to get 12X, 4 times 9 to get 36. Take 36 divided by 12. You probably already knew this solution was 3 by knowing that we have 3 fish per aquarium. That being said, setting up a proportion will always work, no matter what the numbers are. I also want to stress to you that we talked about dimensional analysis earlier this unit, and the same labels went diagonally there. The difference was that we were multiplying fractions in that case. Here we're setting fractions equal to each other. And since equal means same, fish is all on the top, aquariums is all on the bottom. We're not putting those diagonally from each other. All right, let's take a look at number 15. We have 8 pounds for $34 and X pounds for $25.50. We're talking about two things here, pounds and dollars. My first ratio is going to be this 8 pounds for $34, so that's 8 over 34. My second fraction is going to come from the X pounds for $25.50. So we will have X over $25.50. Is this the only ratio you could write? No. Or only proportion you could write? No. You could actually flip-flop both of these, putting dollars over pounds. You could even have like 8 over X equals 34 over $25.50. We'll see that on one of our later multiple choice questions. But let's solve this proportion. So we've got 34 times X, which equals 34X. 8 times 25.50, which is 204. Divide both sides by 34 to get an answer of 6. So our answer will be 6 pounds. Do not forget your label. All right, question number 16. So we have X inches in 0.45 hours, 8.75 inches, and 1.125 hours. So for this one, we're talking about inches and hours. I just keep them in the same order in which they're written. My first ratio is going to be X over 0.45. It's going to be this guy right here. And then my second ratio or fraction is going to be 8.75 over 1.125. So that'll be this guy right here. Let's cross multiply. No need to round at all as you're working through this. So we have 1.125x equals 8.75 times 0.45, which is 3.9375. Divide both sides by 1.125 to get a solution of 3.5 inches. Again, make sure you have the appropriate label. I know it's inches since X is what I'm trying to find, and it's on the top where we have our inches. I did have some Math 7 students when we were working through this ask, do we have to have the inches over hours or pounds over dollars off to the left? You don't need it, but if you are struggling at all, that's a great place to start. All right, let's take a look at number 17, get into some true word problems here. So in number 17, it says the wait time to ride a roller coaster is 20 minutes when 160 people are in line. Write and solve a proportion to determine how long the wait time is when 220 people are in line. So we're talking about two different things, minutes and people. So our first ratio is going to come from this first statement. It's 20 minutes for 160 people to go through line. So 20 over 160. We're trying to figure out the wait time when 220 people are in line. We're talking about 220 people. People's on the bottom, so we put 220 on the bottom. I chose T for time, M for minutes also works as your variable, or if you simply just want to use X every time, that works too. Let's cross multiply. 160 times T is 160T, 20 times 220 is 4,400. Divide both sides by 160, and your wait time when 220 people are in line will be 27.5 minutes, or 27.5 minutes. You could also write it as 27 minutes and 30 seconds would also work. All right, let's take a look at number 18, just working through these problems. Number 18, it says Garcia's grocery store sells Swiss cheese for $2.49 per pound. How much would it cost if Mr. Underkoffler needs to buy 12 ounces? Now, if we're going to find this, we're talking about cost and either number of pounds or number of ounces. My suggestion here, since we're trying to find the cost of 12 ounces, is to use dollars and ounces as your label. Now, you might be thinking, well, how do I deal with this first statement then? $2.49 per pound? Well, that's why we have this hint that there's 16 ounces in a pound. So it's $2.49 for 16 ounces, 1 pound. We want to find the cost for 12 ounces. 12 is going to go on the bottom with our ounces. Let me delete that there. And we will have C over 12, cost for 12. So it's $2.49 for 16 ounces. We want to find the cost for 12 ounces. Let's cross multiply. 16 times C is 16C. $2.49 times 12 is $29.88. Divide both sides by 16. We get exactly 1.8675, but we do need to round to the nearest cent here. So nearest cent means I look at this 6, I visit the neighbor to the right, which is a 7, so this will be rounded to $1.87. All right, let's go ahead and take a look at number 19. Mr. Myers paid $99 for 12 kids to go to a movie. Find the cost for 18 kids. We're talking about the cost and kids. First fraction is going to come from the $99 for 12 kids, so that's 99 over 12. We want to find the cost for 18 kids. It's kids, which is on the bottom, so we put C for cost over 18. Now we cross multiply. So take 12 times C to get 12C. 99 times 18 is 1,782. Divide by 12, and we will get a solution of $148.50. Now, do you need to use proportions to answer this problem? No. You could actually use the constant of proportionality or unit rate to find your solution for this. The way we would do that is find the cost per kid to go to the movies. We would take $99 divided by 12 kids. That gets us $8.25 per kid to go to the movies, and then multiply that by 18. It gets you the same solution, and it's an alternate way to do the problem. If the problem doesn't say you have to use a proportion, you could certainly use this. All right, let's go ahead and take a look at number 20, just rolling right through these questions. Penelope paid $881.25 for 15 friends, including herself, to go to a water park. What would be the total cost if 5 more friends decide to come along? So we're talking about cost compared to the number of people or friends. So we know that it's going to be $881.25 for 15 friends. My goodness, my son keeps going upstairs, downstairs, slamming the door, back and forth. Thank goodness my husband's down there with him. So you have $881.25 for 15 friends or 15 people. We want to find the total cost not just for 5 friends, although you could use that, but 5 more friends. So that means a total of 20 people or 20 friends. So I put 20 on the bottom since we're talking about 20 people and put C for cost on the top. Now again, you could find the cost per friend and then figure out how much it would be for the 5 more friends and add that on to the $881.25. So there are other ways to do this. Since we're working with proportions here, that's why I'm choosing to use proportions in this work. My son's right outside the door right now. Let's go ahead and cross multiply. Take 15 times C to get 15C. 20 times $881.25, which is $17,625. Divide both sides by 15, and the total cost for those 20 people would be $1,175. All right, let's go ahead and take a look at question number 21. So this is a pretty straightforward proportion question. Number 21, it says, Mrs. Garcia is planning a party for her son's birthday. Apparently he thinks it's his birthday. He's walking in the room right now. She knows that 12 tacos are enough to feed 4 people. If 26 people are going to attend the party, how many tacos will she need? So we're talking about the number of tacos compared to the number of people. The door is going to shut here in a moment. You might hear it. There it is. So we're talking about tacos and people. It smells like he needs a diaper change too. So we've got 12 tacos to feed 4 people. So we'll put 12 over 4. And we are trying to feed 26 people. Since we're talking about 26 people, People's on the bottom, so we'll put 26 on the bottom. I chose T for tacos for the top. Let's go ahead and cross multiply. We have 4 times T equals 26 times 12, which is 312. Divide by 4. We're going to need quite a few tacos. 78 tacos. We've got some maracas or something like that my son brought up here, so you may be able to hear those. We end up with 78 tacos needed. All right, so I did throw in, we'll see those practice problems in class, but I did throw in some questions here with currency conversions. It's not going to be on your test, but it's a good real-life application to how we can use proportions for some real-life situations. So I took these rates that are given in the table. I got those at the beginning of 2020 before everything went crazy and everything went downhill. But these rates do really change on a daily basis. Not majorly, but these wouldn't be the exact same probably if you checked on what these rates are today. So it says the table at the right shows the exchange rates for, carefully Oliver, shows the exchange rates for certain countries compared to the US dollar on a given day. For example, the 0.76 for British pounds means that 0.76 British pounds are equivalent to $1. So for the euro, 0.90 euros is equivalent to 1 US dollar. So in number 22, it says, what is the cost of an item in US dollars if it costs 24.99 in British pounds? So we're comparing British pounds, not pounds as in weight, but British pounds compared to the US dollar. So we need to use the conversion rate given in the problem. 0.76 British pounds are equivalent to 1 US dollar. Since we're given a cost of 24.99 British pounds, we're going to put that on the top. So we have 24.99 over D dollars. Now cross multiply. So we will take 0.76 times D equals 24.99. You're basically going to take the cost in British pounds, which is 24.99, divided by the conversion rate of 0.76. Now, in our calculators, we're going to get 32.8815, and it kind of keeps going from there. We do want to round to the nearest cent in this case, so this would be $32.88. So if you were to go to England, for example, and the cost of that item, Oliver, was 24.99 British pounds, then that would actually cost $32.88. So I know that when my husband and I traveled to Italy, for example, and we had a cost in, it's being a little stubborn right now. Oliver, do not slam the door, please. When we had the cost in euros and we used our credit cards, for example, the cost that we had on our receipt in euros wasn't exactly the same that would show up on the credit card statement because it would be using that conversion rate. Let's take a look at number 23. What is the cost of an item in US dollars if it costs 6,5 in euros? So a lot of times you're going to see this 6,5 euros, and that really equals 6.5. We can replace that comma with a decimal point. So let's go ahead and figure this out using the conversion rate given in the table. So we know for comparing euros to dollars, and we could put dollars over euros, but I think it's easier to show it this way. My apologies. My son is sticking tons of Legos right in front of me right now, and he keeps going back and forth. So we've got 0.90 euros equals $1 based on the conversion rate given. So if we're going to have 6.5 euros, we're going to compare that to D dollars. So we have 0.90 D equals 6.5. Divide both sides by 0.90. We get 7.2 repeating. So this would be equivalent to about $7.22. All right, taking a look at number 24. Mrs. Garcia and her husband spent their vacation in Italy, a country which uses the euro. If the cost of their dinner was 125 euros, what is the cost in dollars? Well, we're going to use that conversion rate from the table that's provided. So we're comparing euros to dollars again. Start off with that same conversion rate of 0.90 euros to $1. Put 125 on the top since the cost was 125 euros. Let's cross multiply. 0.90D equals 125. Divide both sides by 0.90. We get 138.8 repeating. Well, we do need to round to the nearest cent, so that would be $138.89. Now again, some of you might recognize that if we're given the cost in euros or pounds or pesos, we can actually just divide by the conversion rate to find the cost in US dollars. Number 25. This summer, Mrs. Garcia went to Mexico. Not really this summer, it was the previous summer. The cost of a Pulmonía taxi ride into town was 140 pesos. What was the cost in dollars? So we're using that last conversion rate that we haven't used up till this point. So we're comparing pesos to dollars, and that conversion rate is 18.84 pesos to 1 US dollar, and the cost was 140 pesos. So I know when we were in Mexico, it was very surprising to me how high the prices seemed, but it really isn't that much in US dollars when you convert because of that conversion rate being such a large number compared to 1 US dollar. So we'll take 18.84 times D, that's equal to 140. 140 divided by 18.84 will get us 7.43099, etc. So about $7.43. So again, even though it was like, 140 pesos, that seems like a lot, that's really only $7.43. All right, rolling right along to number 26. This is a good word problem for us. It's a little bit higher level. We're almost done with these notes. So number 26, it says the ratio of the number of students in the chess club to the number of students on the math team is 1 to 3. The ratio of the number of students on the math team to the number of students on the quiz bowl team is 1 to 2. There are 4 students in the chess club. How many students are on the quiz bowl team? So I started with this first statement. If I know that the ratio of the number of students in the chess club to the number of students on the math team is 1 to 3, and I know that there are 4 students in the chess club, I could set up a proportion. So chess to math is 1 to 3, and we have 4 students in the chess club. So cross multiply to figure out how many students are in the math club. Well, 12 students are in the math club. So then if I know that the ratio of, and I'll highlight this in green, the ratio of the number of students on the math team to the number of students on the quiz bowl team is 1 to 2. So I've got math to quiz bowl here. And I know 12 students are in the math club. I use Q for quiz bowl team. Cross multiply, we'll take 1 times Q is Q, 12 times 2 is 24. So what it means for us is, well, we've got 24 students on the quiz bowl team. So you use each part and just kind of step by step figure out how many students are on the quiz bowl team. Now often I do this question and then students ask, well, is this going to be on the test? Probably not, but it's a good higher level question, especially for you guys as pre-algebra students. The other thing that's not going to be on the test, but that I think is good for us to see, are these extra challenge problems that involve solving proportions, where the top or bottom, the numerator or denominator, is not just x or y or some other variable. It might be something like x minus 3 or x plus 2 or 3 minus y. But we still solve these proportions by cross multiplying. So let's try number 27. Take 6 times x minus 3. You got to put the x minus 3 in parentheses. That equals 14 times 7, which is 98. So between this step and this step, I multiplied 14 by 7 and I distributed. So I did 6 times x to get 6x, 6 times 3 to get 18. Now you just have a 2-step equation. Add 18 to both sides to get 6x equals 116. Divide both sides by 6 to get x equals 19.3 repeating. I did make these questions so you don't end up with nice round numbers because I don't want you to do it mentally. I want you to be able to do the math cross multiplication that can be used to find your solution. All right, let's go ahead and take a look at number 28. So take 5 times x plus 2, put the x plus 2 in parentheses, set that equal to 3 times 6, which is 18. I'm going to distribute in that same step to get 5x plus 10 equals 18. We'll solve that 2-step equation by subtracting 10 from both sides. I'm sorry, I can't help by laughing because he just said, here's some poop. No, thank you. We're going to subtract, he just brought an empty cup over here, so he's being a little goofy right now. That's what happens when you have a 3-year-old. So we subtract 10 from both sides to get 5x equals...
Okay. Get this.
Subtract 10 from both sides to get 5x equals 8.
Okay, I'm going to get you spoon. This, yeah?
Oh, it's a spoon. Okay, thank you.
No, I'm going to get you.
So we'll divide both sides by 5. I'm sorry. Divide both sides by 5 to get a solution of x equals 1.6. All right, let's try one more of these, hopefully uninterrupted by spoons, maybe? I don't know. We'll take 9 times in parentheses 3 minus y equals 4 times 1, which is 4. Distribute, 9 times 3 is 27, minus 9 times y. So we have 27 minus 9y equals 4. Don't forget, though, if your variable comes after subtraction, you should add the opposite. So I wrote this as 27 plus negative 9y equals 4. Subtract 27 from both sides to get negative 9y equals negative 23. Divide both sides by negative 9. Thank you. You brought me some ice cream.
I'll get Daddy's ice cream.
Get Daddy ice cream? Okay. Divide both sides by negative 9. And this will get us y equals 2.5 repeating for our solution. Again, you're not going to have any questions like numbers 27 through 29 on your test, but this is something you will see in the future, probably even as early as next year. All right, one last question from these guided notes. This kind of question will show up on your test. So number 30, Cooper typed 230 words in 5 minutes during his typing test. Which of the following proportions could not be used to determine how long it would take Cooper to type 391 words? So we're talking about words and minutes. So I set up the ratio of 230 words for 5 minutes. We're trying to figure out how long it's going to take him to type 391 words. So that will go on the top. Now this one directly matches choice A. So choice A is not the one we're looking for because we're looking for the one that will not work. This one will. Now you might be thinking, well, how do I know which of these ones doesn't work? Here's what I would do. To solve this proportion, you would do 230 times x. Figure out which of these would not involve doing 230 times x to get your solution. Choice B, 230 times 5. That's not 230 times x. Choice C, 230 times x. I would also take 5 times 391, which I would do here. So C would also work. D, 230 times x and 5 times 391. That's what I would do for this proportion down at the bottom that I know works. So the one that does not work for us is going to be choice B. All right, I know this is a pretty lengthy video, but again, that's going through all of those questions, which we probably wouldn't just see in one day in a regular class period anyway, but I wanted to make sure we put them all together in one video. So if you need to see any of these things, you can scroll through and find those questions that you need to take a closer look at. Thanks for listening, and thanks for dealing with my crazy 3-year-old.